Okay, so here we are at the last part of this unit, and you're going to learn how to calculate something called percent yield. So let me give you a quick definition of what percent yield is. So imagine that you're a scientist. It kind of looks like an evil scientist, but imagine that you're a scientist and you go to a lab and you want to do an experiment. Okay, so you have these two reactants. One of them is orange, and one of them is green, and you're gonna mix these together and you're gonna make some sort of cool product. Okay, but because you're a good scientist, you first do some calculations to figure out, oh, if I mix these two reactants together, what is the theoretical amount of product I should get? And that is the theoretical yield. Okay, so let's say you calculated in your calculations that you should get 50 grams of a product. Okay, that's before you even start the reaction. So that's what we have learned to do now. We know how to calculate based on the masses of our reactants, the theoretical yield, like how much product we should actually get. And we know how to calculate what is the limiting one and what is the excess reactant. So it could be the orange one or the green one, but you expect to get 50 grams of product at the end because that's what you calculated theoretically. Okay, so you go to the lab and you mix these things together, but when you mix them together, okay, you get a product, and that product is actually only 30 grams. You measure the product and you're like, wait, I only have 30 grams of product. Why do I only have 30 grams of product? And that is the problem that you actually might need to solve as a scientist. Okay, but we are looking at the numbers here. So you have 30 theoretical yield, you expect to get 50 grams of product, but in reality, in actuality, in the real lab, in real life, you only got 30 grams of product. And this is what we call the actual yield. Okay, now you're going to learn how to calculate what the percent yield is. The percent yield is basically the ratio in percentage between the 50 grams of product that you expected to get and the 30 grams of product that you actually got. So percent yield is a way to calculate how much of the original calculated product did you actually get when you did the experiment. Okay, so just an example from real life, the other day I baked some strawberry muffins, and the recipe said that it was enough to make 12 muffins. But when I actually filled the muffin cups, I actually ran out at 9 muffins, and they weren't like very giant muffins, they were this normal muffin size. So even though the recipe technically said I should get 12 muffins, I only in real life, when I baked, I only got 9 muffins. Okay, so there is a discrepancy between theoretically how much I should get, how many muffins, and how many muffins I should get, or how many muffins I actually got in real life. Okay, so I could actually calculate a percentage or percent yield of muffins using the same principle. Okay, so let's look at the very simple equation you're going to use to do this percent yield calculation. Okay, so it's gonna be percent yield is equal to the actual yield, like how much did you actually get from an experiment in the lab, versus the theoretical yield, so actual yield over the theoretical yield, that's the amount you got from your calculations, times 100. Super easy, okay? But in order to do this kind of calculation, we both need the actual and the theoretical yield, okay? So let's read this problem. 25 grams of zinc is added to excess hydrochloric acid. So let's read that sentence. Excess hydrochloric acid is identified as the excess reactant. So if this is already identified in the problem, you don't need to do a calculation to find the limiting reactant and the excess reactant. It already tells you that hydrochloric acid is excess, okay? And over here, it tells you that 25 grams of zinc is used. The zinc is going to be the limiting reactant. Okay, so the zinc is the limiting reactant and the hydrochloric acid is excess. When you mix them together, you get 0.680 grams of H2 gas in the lab. So if it's in the lab, they have given us the actual yield of H2 gas or hydrogen gas. Okay, so we have to find the percent yield of hydrogen, percent yield of H2, based on this equation. So remember, in order to calculate percent yield, in order to calculate percent yield, I always forget the L for some reason. In order to calculate percent yield, you need actual yield. So I'm going to take actual yield over theoretical yield times 100. So we have the first piece, we have the actual yield, but we still have to find the theoretical yield. And in order to find the theoretical yield, we need the limiting reactant. So that's why we have 25 grams of the limiting reactant already given to us. Okay, so 25 grams of zinc. Super easy, right? Just a mass to mass calculation to find the grams of hydrogen. And why hydrogen, you ask? Because that's the actual yield product that's given to us. This equation has zinc chloride and hydrogen as a product, but we are picking hydrogen because that's what the problem has already picked for us. Okay, so I'm going to go from 25 grams of zinc, which is the limiting reactant, to find grams of hydrogen, the theoretical yield of hydrogen I should get if I react 25 grams of zinc. So first conversion factor is the molar mass. That's going to be 1 mole of zinc over 65.39 grams of zinc. Grams on the bottom with the molar mass because grams have to cancel out. Then we're going to compare the mole ratio between zinc and H2. That's 1 to 1. So that's super easy. 1 mole of zinc for every 1 mole of H2. And it's H2 because hydrogen gas is diatomic and that's the product. And 1 mole of zinc on the bottom because I have 1 moles to cancel out. Okay. Then we need the molar mass of hydrogen, and that's actually 2.02. Remember, hydrogen is diatomic, so 2.02 grams of hydrogen for every 1 mole of H2. There we go, all set up. Now let's see, grams of zinc cancel out, moles of zinc also zinc cancel out, moles of H2 cancel out. Perfect, 25 grams divided by 65.39 times 2.02 gives us 0.772 grams of zinc. Now look at the two numbers. 0.772 is your theoretical yield. This is your theoretical yield. That means that is theoretically, based on your calculation in your book, how much hydrogen you should get. But 0.680 grams of hydrogen is what you actually got. So there's a discrepancy between what you calculated you should get and what you actually got. Like I figured based on the recipe, I should get 12 muffins, but I only got 9 muffins. Okay, so based on that, you can actually calculate your percent yield. So this is going to be actual yield 0.680 grams on the top, 0.772 grams on the bottom, actual over theoretical times 100. That gives me 88.808%. So what that really means is I expected to get 0.772 grams of hydrogen when I reacted 25 grams of zinc, but I only got 88.08% of that 0.772. Okay,